Okay, everybody. So, energy. The objective of today is we're going to introduce you to 9 different types of energies. The goal is that you can recognize it when you see it. So in our activity today, that's what we'll be doing is I'll be showing you a picture of something, and as a table, you'll have to try to figure out, okay, what types of energies happen in this type of system. Okay, so let's kind of go through all the different types. Some you may be familiar with, some maybe not so much. Okay, so the first thing, as I mentioned, is that energy is always conserved, right? It doesn't go away. It doesn't just come from nothing. It had to come from something. So it's never created or destroyed are the next 2 blanks. Okay, key component about energy, right, is energy has the ability to do work. But the difference is from what we've talked about all year is energy is not matter. So we've talked a lot about matter. So define matter again. Matter is anything that has mass and takes up space. Okay, anything that has mass and takes up space is considered matter. Energy is not matter. It doesn't have mass and it doesn't take up space, but it has this ability to do work. Okay, so keep that in mind as we go through our different types of energy here. Okay, so as we mentioned, energy is always conserved. It's the law of conservation of energy, but it often just gets transferred. We're not going to do any math in this unit, but we will talk about energy because energy is a mathematical thing. A very common unit used for energy that maybe you're not familiar with is the unit of a joule. It's a measurement of energy. Some other ones we'll talk about that you're maybe more familiar with are voltage. Right? Voltage is a form of energy. Calories is a form of energy in terms of a unit, but joules is maybe one you're not as familiar with. Okay, so our first type of energy, so this is the first box right here. So you'll put the type of energy, so it's kinetic energy, describe what it is, and then we'll put our examples in the last box. So this is the first one you should fill in right here. So kinetic energy is the energy of something because it is in motion. Kinetic energy is the energy of something has because it's in motion. And then your example is a wind turbine. It initially works through kinetic energy, and then that kinetic gets turned into electrical, which is obviously then how we benefit from it. So in our activity today, you'll be doing a lot of this. We'll be talking about, okay, it starts in this form of energy, and then it gets transferred into this form of energy. And then maybe more steps down the road. Okay? For smiley face by raise a hand, can someone else give me another example of something with kinetic energy? So with a car, so you got to think of like, does the car naturally move on its own? So it is kinetic in that it's moving, but it's getting that energy. So I guess you could say in a car, it goes from chemical, because that's your gasoline burning, or I guess electrical if you have a Tesla, right? And then it gets turned into kinetic energy to move the car. So in that sense, it's like ending in kinetic, right? Good, Oliver. Sam? Perfect. And we'll actually talk about gravity as one of our types of energy. So that one has the combination, if you're going down a hill, that you have the gravitational, and then it gets turned into the kinetic, which then you can still continue to use even when you get onto a flat surface, right? Good. Sam, have a smiley face. One more. Anyone? Hayden? Waterfall. Why is that kinetic? Yeah, good. And I'd also say that also will bring in, also plays a little bit into gravitational as well, because it's the downward fall is what making it, but it's part of the kinetic as well. Caitlin? Yeah, in a sense, it's a kinetic movement. Is that energy used for anything purposeful to us? No. But sometimes you'll find there's a lot of energy that is, I don't know if you could say wasteful sounds like mean, but wasteful in the sense of like we're not using that energy for any direct purpose, but there's still energy there for sure. Good, Caitlin, I have a smiley face for that as well. Okay, energy type number 2 is gravitational potential energy, which was already kind of brought up here. So gravitational potential energy is the energy something has when it's away from a center of gravity. Now, keyword here is the potential, right? Means like the energy is stored. Like the energy is not being used yet, but it has the potential to use that energy. The higher off the ground something is, the more gravitational potential energy it has. Anyone, while we're filling that in, we kind of gave some that already linked to gravitational, but anyone have any other different ones that we could put as something that has gravitational potential energy that we maybe use to help us or is just there? Say it again. Yeah, a meteor has tons of gravitational potential energy, right? Which you see the result of that potential energy by the craters they could leave in the ground, right? Good. Caleb has my face for that. Oliver? Yeah, just the falling of it back down is going off of the gravitational potential energy. Good. Yeah. Yeah, Pacey. Skydiving. Yep. Right? Like when you're up that high, like you don't have energy until you get out of the plane. But then once you get out of the plane, you're benefiting, I don't know if benefiting is the right word, but you're using gravitational potential energy to get you back down. Very good. How's my face for that? Caitlin. Oh, yeah. Diving board would be another great example. That diving board has a good amount of gravitational potential energy. Good. Okay, everybody okay here if I go to the next one? Okay, energy type number 3, okay, is nuclear potential energy. Now, we actually talked about this a little bit already in Unit 2 when we were introduced to nuclear reactions. So to remind you, nuclear reactions are when we talked about alpha decay, beta decay, gamma, half-life, and things like that. And then fission and fusion. So the real power of a nuclear process is in fission and fusion. This is stored energy inside a nucleus. That there's energy within the nucleus that can be used and come out if you cause it to undergo fission or fusion. Now this one's maybe not all around us. Anyone know of where places where nuclear potential energy might be being used? Okay. Yeah, a nuclear bomb, right? That's in a sense all the energy that comes out of a nuclear bomb is nuclear potential energy or is nuclear energy. Do you guys remember when we did our unit and we like pulled up a map and we dropped bombs on Sky Ridge? Do you remember that day, right? And the difference between a chemical explosion versus the nuclear explosion that went from like Layton to Payson or something like that, right? Oliver? It could, it depends. So we do actually use nuclear power for some things, like a lot of submarines run off nuclear power now actually, as well as like aircraft carriers. And I know that there's some rocket spaceships that actually do use nuclear power. Not all of them do, but like some of them do. So yeah, definitely could be. Yeah, Jane. The sun. How was my face that? Yep, the sun literally runs off of nuclear power. Yeah, very good. Okay, everybody okay? Give me a wave if you're not, because I can wait. Okay, number 4, is that what we're on? Number 4 is electrical potential energy. So electrical energy is created when charges, aka electrons, move around. So anything with a charge has the potential to create electric energy. So if you've never thought about it before, all electricity is flowing electrons. That's what electricity literally is it's the flow and movement of electrons from one place to another. It goes through your phone, and that movement of the electrons causes energy. in the form, once again, of what we call electrical energy. So when you see like a lightning bolt in the sky, in a sense, like you're seeing electrons connecting to each other. And then you see it transferred into a little bit of light energy and sound energy as well with the thunder. I guess I should say we call it sonic energy for sound. Anyone have any examples of things that have electrical potential energy? Batteries, perfect example. And that's what we'll do actually for our lab when we learn more about this one day, is we'll make a battery. It's the simplest but most common use we see of electrical energy. Anyone have any other thoughts of something that has electrical potential? Yeah.
I just have a question.
Yeah.
It can't be matter, so how is it like this just moving electrons? Like it's like kinetic energy just doing stuff. But like how is that not?
So it's the movement of the electrons. It's kind of weird because I was thinking about this the other day actually, of how like electrical is kind of kinetic because it's about movement still. It's just a movement of a very particular thing of charges. The difference is with the electrical is what's causing it is just a difference of a positive and negative, and that's causing the flow. And so that side of it being, that isn't matter. Does that kind of make sense? Like matter is involved in it to like cause the flow to happen, but the actual energy itself isn't like a tangible thing with mass that you can hold. Yeah. Does that make sense? Yeah, good question, Taylor. Okay, everybody okay here? Okay, elastic potential energy is the energy that's created when a spring or cord holds tension like a rubber band about to snap. Okay, so elastic potential energy, think of rubber band or spring. Oh, thank you. One thing, keep in mind, every time I'm using that word potential, it just means some things have it, but maybe it's not being used like a rubber band. Not until you pull it, now it has the energy. Yeah. Yeah. This is just my hypothesis. I don't know, Sam. I would guess it's too small. That, because, yeah, the laws by which, like, we use the energy can be very different compared to, like, at that level. That's just my guess, but I don't know. That's a really good question. Yeah, Jane. Yeah, so then that potential goes away. And then in a sense, once you're on the ground, then it's no more energy, right? Like you've lost all that energy in the fall. So does that make sense? Anyone think of any examples of some device or something that uses gravitational potential? Yeah. Yeah, because it's doing like this motion. Yeah, I would say so. I definitely call that gravitational. Good one, Hayden. Have a smiley face for that. Kate? Yep, and that's in a sense what that video is all about, is a Rube Goldberg machine. But yeah, good one, Kate. Have a smiley face for that. One more. Maybe you have one like in your backyard. Yeah, a trampoline, right? Because the springs of it, in a sense, it's the same concept. So, Caitlin. Yeah, so it's like you start with like using the gravitational helps you then to maximize. I don't know which one comes first. I guess because to start a tramp, you jump up. And so you start by using gravitational, and then the elastic helps even more. I know, do you start like, that's true. But I guess like even when you get on it, you still like, I'm trying to think, like you always go up before you go down, I guess. Yeah, good one. Okay, everyone good here? Okay, next one, electromagnetic energy. Okay, electromagnetic energy is the energy that is given off by light waves. Okay, keyword here to simplify this big word is light. Okay, electromagnetic energy is about light waves. Now keep in mind with light waves, right, we have the light that we're used to seeing, but then there's also types of light that you don't directly see, right, like black lights, infrared, but those are still classifications of light. Okay, so something that turns electromagnetic energy into usable mechanical energy is solar panels. So they're taking, so the light that comes from the sun, we would classify as electromagnetic. And sometimes when you learn about these types of energy in like younger years, they just call this light energy. But it's like official name is electromagnetic energy. Can anybody think of some examples of things that work through electromagnetic? Yeah, Oliver. Yeah, microwave for sure. Yep, they're taking electrical, right? But then it gets turned into not just electromagnetic, but other ones as well. Yeah, good one. Anyone else have an example? Yeah. Yeah, a radio works through electromagnetic. Good. Caleb? X-rays, good. I'm holding one in my hand right now.
Remote.
Do you know how a remote works? So like remotes, everybody, right, look right here. Right, so it has a little, all remotes have like a little bulb, right? Right, so when I point it, it's sending infrared light, so I can't see it, but in a sense, it's shooting a laser out of here to the signal, right? And so it's working through using that, right? So if you cover this little bulb up, your remote won't work, right? Yeah. I would say it definitely has like, it does have electromagnetic, it's almost electromagnetic radiation is the result. Like they don't work off of it, but the energy that comes out is, we would call the laser itself electromagnetic. Does that make sense? But yeah, they don't work through it, but they produce it, maybe is a good way of saying it. Okay, everybody good there? Okay, next one, chemical potential energy. This is the potential energy that results because of chemical bonds. Okay, so when chemicals react, and we'll have a whole day about this one as well. I think it's next time, actually. I think this is the one we start with, where we have like a day in the lab where we focus on it. The chemical potential energy is the energy that results from a chemical reaction. Okay, so when a chemical reaction occurs and energy is produced, it's called chemical potential energy. It gave you one, again, that we've already talked about because there's a connection between both, that batteries have a chemical reaction inside of them. That chemical reaction then gets turned into electrical, as Caleb brought up, and then that's how we use them. Can anyone think of something else that works through a chemical reaction?
Fire.
Fire, right? Any sort of explosion, that is, you're seeing the chemical potential energy coming out. Yep. Anyone else have another example for us? I also said it before, but it's kind of the same idea because it is fire, but the burning of gasoline in your car, right? Your car runs through the chemical energy in the gasoline as it's being burned, right? And then the pistons move and things turn and turns into kinetic and a lot of different energy going on there. Okay, everybody okay? All right, sonic energy is the energy of sound waves. Okay, so once again, if you've learned about this in younger classes, sometimes they just call this sound energy. It is, it's just sonic's the fancy word. Okay, this type of energy can only be transmitted through the air. Once again, sound doesn't get transferred through empty space. Those waves don't travel that way. This one to me, like there's a lot of sound around us. I would say, I don't know if we have a ton of ways in which sound energy is used productively outside of like communication is productive, but like things that actually run off of sonic energy, I don't know if we've yet come up with ways where, but any ideas? Yeah, a speaker in a sense puts out sonic energy. So keep that in mind. If you write down speaker, keep in mind it's not like running off of sound, but it's turning electrical into sonic. Yeah, good one, Oliver. Okay.
Voice commands.
Oh yeah. Yeah, in a sense we actually are using our energy. That's a good one, Kate, right? So when you talk to your phone or to your Alexa, you're literally using your sound energy. Would you say then it's going sonic to electric, kinda? Because it's like then activating it. Yeah, that's a good one. Questions on sonic energy? Was that 9? Oh, one more. Okay, is this our last one? Okay, thermal energy is the energy of heat. Okay, so heat, if there's heat given off, we classify that as thermal energy. There's kind of a reason why this one is listed last, is this one is often one of the ones, once again, we consider as waste, where a lot of reactions end with thermal energy, but that thermal doesn't get used for anything else. It kind of ends if you think of our video at the beginning, how there's this domino process, a lot of times the end result is there's thermal, and the thermal just goes out into the universe. But it's not then used for something else. Some use it, but often it's just, the heat's just dissipated. So can anyone think of an example of anything that uses or puts off thermal heat besides fire? Yeah. Yeah, a hand warmer. And so those would be examples of chemical transferred into thermal, right? Because they start as a chemical reaction, that's how they work, but then they put out a thermal. Good one. Kaya, have a smiley face for that. Easy. Yeah, for sure. So stove and oven would be like starting in electrical and then transferred into thermal. Yeah, good one. Lava. Yes, that would be a natural one, right? That just like comes from the process. Good. Have a smiley face for that, you too. Okay, any questions on, oh yeah, Cameron, go ahead. Yeah, so the sun, let's see. So sun, our flow would be, it starts as nuclear, but then the nuclear gets transferred into a lot of thermal for sure. You'd also probably then also add like some electromagnetic because of the light. So yeah, good one. Okay, any other questions on our definitions before we try our little activity here? Okay, so in the goal of our activity, okay, what's going to be happening is you're going to be working as a table. Okay, let me pass out the paper. It's kind of blank, but that way you have it to look at. And then I'll explain here. Let's see, everyone at least has, yeah, I was going to say some tables aren't full, but everyone has at least 3. You've just so you know, you lost your engagement in points today because if you're on something else and you're not being engaged with what we're learning, unless it was this, but I know it wasn't that. Okay, so you'll work as a table, but everybody needs their own paper. Mm-hmm.
And I hate this one.
Okay. Okay, so here's how this works, everybody. The goal is, by the way, that you should be able to finish this before you leave today and not have to do it as homework, because I want you to be working collaboratively and not have to just do it on your own. So that is dependent somewhat on you using your time wisely as a group and not getting distracted. But if you stay focused, you should have time to get it done. Okay, so what's going to happen is there are 9 different household items that I have in picture form. Okay, as a group, you are going to first, you're going to just draw a very simple, it could be more complicated if you want to be, but a very simple picture of what the item is in the box. Okay, then as a team, you're going to decide what type of energies exist in this appliance. Okay, the goal is to show the flow of energy, meaning, okay, it starts in this form, and then it goes to this form, and then maybe this form, and this form. I'll give you some hints in the beginning of like how many energies there are. The last ones I won't give you any hints for, but just to kind of build you up. Okay, in order to move on to the next level, you have to pass off the first one. Okay, so once you have the first one and you think you've got it, this says to come up. I'll walk around. So you just raise your hand. I'll come around. If you pass off, then I'll give you the next card. If you don't pass it off, then I'll tell you. Then you try again until you pass it off. Any questions on what you're doing? Okay, perfect. All right, let me stop the video real quick, and then we'll give you all your card number 1.